following Simon's talk, I will also show you how you can utilize LocalStack for deploying a data streaming application. So maybe let's first look into a broader overview what actually data streaming is. So why is it not switching? No, it switched too far. Okay. So in general, when we have been doing data processing in the past, we mostly use batch processing. But now more and more data streaming and processing data in streaming services is coming into like applicational development. And this is mainly, I think, to three main reasons. So one big reason is that you can process data near real time, especially like utilizing AWS services. You can, very, very small latencies with putting data through your system. Also, these services tend to be way more scalable and also reduce like throughput and latency to the scalability of the services. And due to their design, they tend to be way more fault tolerant, because even if you encounter some issues, you don't necessarily lose batches or have to restart from a batch processing part, but you only use a very, very small increments, and they are like fault isolated to these small increments. And AWS has quite a number of data streaming services available. But in general, if you start out fresh, you would switch to Kinesis, because Kinesis, this is basically their primary offering of data streaming service in the AWS ecosystem. And this is due to several reasons. Mostly the reason it is fully managed, so you have to, if you don't want to configure the least amount of things under the hood, and it runs more or less right out of the box as you intended to run. It's very scalable, so you can configure it to auto scale up and down depending on your throughput volume, and this of course helps you to reduce cost and in the end save you money, which is always a intended thing, especially when deploying large workloads on AWS or on any cloud provider. And it also is it's deeply integrated with other services. So it is out of the box integrated with a lot of other services downrange as consumers, but also a lot of services can directly write into Kinesis data streams without having you to use some kind of Kinesis client library to configure it. But of course, you can also send data from your endpoints, from mobile devices into it. So I said we are going to look at a more or less real life business case to then use this to see how can we use and leverage data streaming services, Kinesis, something around Kinesis. And a business use case which I encountered in real life with a large company already is a bit abstracted, but basically you have a novel device where you can generate or gather some health data. This could be heart rates or some more abstract measurements you do with your users. This hardware device is connected to your mobile device, and the mobile device then sends this data to your cloud pipeline. And you want to have, maybe you're a smaller company or you're a larger company and you already know that you're going to have thousands to millions of customers, but you want to basically be able to scale. So it makes sense to keep that in mind, to be able to scale to your next big unicorn, to have millions of devices. Every second person will use your novel hardware tracker. And you also want to be able to query this data. On the one hand, maybe to train your models, to do predictions, maybe in real time with this data which is coming in, but also for your data scientists to use the vast amount of data you're going to build with your new unicorn startup to generate better models to make better predictions. So considering this business case, we have to get together as engineers, and we have to think, okay, how can we basically provide an infrastructure, a target architecture that fulfills these requirements? And in this case, we looked at the offerings from AWS and we said, okay, Kinesis is the way to go for us, but we also want to be able to give our data scientists a way to query the data. So we need to store it somewhere. And most of our data scientists, they're happy to work with Jupyter and SQL. So we found Redshift as the suitable storage, data storage for these devices to be able to also work with machine learning models maybe in the future. And to distribute data from our streaming service, where our clients are writing these into the stream, to our data storage, we are going to use AWS and also Amazon Data Firehose. We recently renamed it, I think last week, because it was named Kinesis Data Firehose, and they probably thought, okay, too complex. They renamed it, so now it's a bit more simpler. And how this will work is that Kinesis can directly connect to Amazon Data Firehose, and this then lets us write to additional services. So Data Firehose in this case, and in a lot of other cases, is kind of the glue in between services to distribute data. This is also probably why they call it like the fire hose, to spray data from somewhere to somewhere else. And we also want to store the data in a S3 bucket for later retention, so that just to make sure that we have always the raw data. And then how Data Firehose in this case distributes it to Redshift is that we store it in an intermediate bucket, and then Redshift read operation is triggered from there to read it from this bucket. In this particular instance, also because we are going to right away implement the tech stack that will work against AWS, not only LocalStack, we have to consider that AWS, from good reasons, doesn't want us to directly connect to Redshift. So it is in a private subnet in our VPC. And so there we also have to configure a EC2 instance, which we can then SSH down through it, which is at a later stage important. Okay, so enough talk. Now let's switch to actually showing you how you would build that with LocalStack. So first thing, you would probably set up your environment. There we have excellent guides on how you can do that. You have to use Docker, some similar runtime environment that enables Docker commands. So Docker Desktop usually is the way to go. And you have to set up your dev environment. In my case, in this case, because we are also internally working with Python, I'm going to do that in Python. And I'm going to implement the target architecture using AWS's Cloud Developer Kit, which is a way to define infrastructure as code, programmatically define this infrastructure. So let's switch over to the demo I prepared. So let's get rid of this because this is already working. So if you want to work with CDK, you have to follow some principles which are quite well documented. So we are going to create this application, and with this application we can bootstrap and then deploy our stack, which we are going to define first the stack in a separate class. So let's also get rid of that because we want to basically start from scratch. So in this case, what would be the first thing which we want to deploy? So the first thing which would be probably the Kinesis stream. So in this case, we can look at the documentation and think, okay, we have a nice sample construct. So with CDK, you have several levels of constructs. There are L1 constructs, which are direct mappings of to CloudFormation commands. And you also have L2 constructs, which are more abstract. So AWS does the work for you. They think of how do you want to deploy, what is actually necessary to deploy a complex resource, and then they map that to an L2 construct. Sadly, for our use case, there are no L2 constructs available, neither for Firehose nor for Redshift, so we have to implement most of it ourselves. But let's get started with that. Let's basically first see how we can set up a Kinesis stream. So here we define it, we give it a constructor, and we define how many shards we have. For that, one shard is enough, and how we want to provision it. In this case, we want to have a provisioned, not the on-demand stack. Then we're going to import it here. And we are going to define it. So we're going to build it here. Let's say we are giving it that. And then now what we can do in the past, or what you usually would do, would now deploy the stack against AWS. But we can leverage LocalStack to speed up that process. So let's first start our LocalStack container. So we can see here that on our Docker, our LocalStack container started. And let's also see that no services are currently running. So this queries our health endpoint, and we can select or filter it against running services because we give you that information. We see, okay, our LocalStack container is running and no service is deployed. So let's now bootstrap that and deploy it. So first, because we're always starting fresh, we have to install the necessary requirements with bootstrapping our environment. This can be done here. This command, so we also supply a Node.js application which mimics the CDK application, and we call it CDK local, and with that you can interact with. That is not what I intended for that demo. So we are seeing that we are bootstrapping our stack. This deploys some required resources for CDK, for the CloudFormation deployment. Perfect. The next step would be CDK local to synthesize. So basically generate our CloudFormation template, which is then used to deploy the declared resources. In this case, only our Kinesis stream. And then now we can deploy it. And we have to declare our stack here. Let's wait a few seconds. Yeah, there we're seeing the operations that happen in the background on our container. Okay, so now if we again query, and yes, now we should, this is not well formatted. Now we should see that we have several instances running. We have the Kinesis stream running, we have an S3 bucket running, because the S3 bucket is required by CloudFormation. We have these services running. Okay, so generally this would be basically the first step. But this is not our target architecture, so we still have to deploy some other resources. And this would be, for example, we have to deploy an S3 bucket. So for that, we can again look at the documentation. What would be the definition of how we declare an S3 bucket in CDK in Python? And therefore, we first have to import the module, and then we can declare it here. Other things we also have to consider, because we intend to be able to also run it against AWS, we have to define the correct policies. So in this case, this will probably also, if you use IAM policy streaming, it can help you leverage LocalStack to quicker iterate to find the correct policies. I have now done the work for you. So I already did that iterative process to see what the right policies would be. And if we have that, then we can actually look at the next component, which would be Firehose. So in this case, we have to look at how can we define Firehose that it knows that it should listen to a Kinesis stream and that it knows it should write to the correct S3 bucket. So therefore, we have to declare several other things. So let me copy that over, because this is quite a lot of code, and then we can go through it. So first, we have to define we have to define the Firehose Kinesis source configuration. So this tells Firehose, okay, listen to this Kinesis source stream as source. There's also a thing that if you want to get logging on errors, we have to create a log group and define this log group. We have to specify the role that Firehose uses to access the S3 bucket. And we have to define a configuration for Firehose to know to write to this S3 bucket. And then here we can actually create the Firehose stream. So let's test that out. Let's import first all the required dependencies. That should be done. And then we can switch back to this. We can run again. Synthesize to update our CDK definition to add the new resources. And then we can deploy it. And now what it will do, it will generate a change set and we'll only look for the change resources and deploy that to our LocalStack running container in the background. So it will ask us and we say, yes, let's do it. And if we copy or we made all the correct configurations, which in general is an iterative process. So what you're seeing here is the result of me iterating through it, reading through the documentation, figuring out where I made some mistakes. And LocalStack vastly sped up this process because I don't always have to wait until the resource is deployed in the cloud, which generally takes longer, but I can deploy it locally and quicker iterate on it. Now, let's hope that I didn't jinx it with saying that it's quicker. But we are seeing that things happening in the background. Yes, now I deployed. And now we can again look on what services are running. And there is our Firehose now running also, which is nice. Okay, this would be the first step. The second step, I guess, would be to bring in Redshift. Now, there's a bit of an issue because if you to configure the destination or from Firehose that it is Redshift, we first have to have a running Redshift cluster. So we have to split up our stack. We first have to deploy the Redshift stack, wait until this is running, and then we can query some information from that to deploy our Firehose stack. So I also prepared that already for us, so we can now go a bit quicker through it. So this would be, in our case, the Redshift cluster. And then we also have to add a second thing, a second configuration to our Firehose, which is the Redshift destination configuration. And the documentation is sadly a bit sparse for that, but yeah, and this will also be probably made available to you via our templates and examples. So now, just to be sure that we don't mess up anything with our existing deployment, I'm going to stop our container and restart it. So basically start out from scratch. So we know that we are not interfering with anything. And yes, I also made a small make script, which will just run through the bootstrapping, the synthesizing, and the deployment of both the stacks. So we can run that, not this one, and deploy it locally. And let's hope that we made enough offerings to the demo gods that this will also run smoothly now. I think last time I ran it, it took about 2 minutes. But what I want to show you in between, in the meanwhile, is that comparing how fast it takes to deploy that for LocalStack compared to AWS. And I made a small video basically executing both of these commands side by side to show how fast this takes. I mean, this varies a bit, but overall, these were the numbers I got. And I guess we will not sit through the whole video because 23 minutes is quite a long time, even though I sped it up. But we can see that we are here a bit ahead on AWS because the bootstrapping step is already done for us because we are not going to bootstrap the AWS environment all the time. And yeah, after, what was it? I didn't even pay attention, 2 minutes, LocalStack is already done and AWS is not even deployed the first part, so our Redshift stack. Of course, this is also an issue because Redshift tends to take quite long. So for simpler stacks, this will be not such a big discrepancy. But again, we can see if you are still in the iterative approach, this vastly increases your development time because you can quicker deploy and redeploy. So let's look at that. Okay, we still have not deployed it successfully, but we already deployed the second part, the Firehose stack. So let's give it a few more seconds. Meanwhile, I can yes, so now it's deployed. So what do we want to do next? So next we want to simulate our pipelines. We want to put some data in to the Kinesis stream and see where it ends up and see if it actually ends up in our Redshift database. So for that, I just wrote a small mock producer and we can run that with, again, a make file. And this is just, yeah, it just puts data into our Kinesis stream and then simulating again, and let's say a data scientist who would use a Jupyter notebook to investigate that data. We can now, let's first look at the raw data in S3 bucket. So what I'm doing here is I'm using a Boto client to locally look at the LocalStack S3 bucket, which we created with our stack. And let's see, okay, so there's already data in there. It's a bit messy, but we see that data is coming into our bucket. And this should increase actually, yes, because I'm basically every 10 seconds, I'm putting new data into the Kinesis stream. So let's look at the Redshift database. So I'm just connecting to the table we set up and defined locally. And we are also getting data in here, which is again also increasing. Just as a simple demonstration, this would be not probably your next unicorn startup if you only generate this kind of data, but to show feasibility, this is how data would end up. And you can then, for example, visualize it, which makes no sense because this is completely random generated data. But yeah, you get the point. So this is basically how you would leverage Kinesis, Firehose, and Redshift on LocalStack. And again, taking this time savings into consideration, it vastly speeds up your process. Also, what is it? Let's move to the next slide. A real benefit if using LocalStack, especially in the beginning of the dev process, but also later on, if you want to test something, you can completely set up your dev environment if you have the infrastructure as code and test new code against it. This is especially interesting if you have large data sets and you want to introduce, for example, you want to change the data layouts or want to change something with the data and you don't want to risk anything with your processing and data which is in production. You can, of course, have several accounts, but then again, you run into this problem. What if you have a lot of developers? You will probably not have one account for each, so they will also step on each other's toes. Yes, that's what you can get rid of with LocalStack. And in addition, this is what in this case is maybe a feature, especially looking at Redshift. You don't have to jump to these hoops with connecting to an EC2 instance because you cannot access your Redshift database, because when you run it locally, you can directly access it. So yes, that would be actually it from my side from this presentation. I hope you got a nice intro into how you can leverage that. This is a feature which we're currently working on, and the complete pipeline you saw will be available quite soon.